So, good evening, my dear students. Myself is Ansuman Chakraborty, as all of you know, are very well acquainted on seeing me from time to time as the administrator of Arjuna Institute of Technical Education and Research. That all of you know is the technical educational wing of Prantik. And you also know very well that I have been taking up in this semester the paper of JCST T006, that is the paper of Fundamentals of Geology and Geomorphology. And over the last 10 classes or 11 classes that I have taken, I have completed out the topics pertaining to the basic concepts in geomorphology, interior of the earth, the different types of rocks. After that, I have discussed about the basic work of the rivers, that is the landform of the rivers in the upper course, middle course and lower course, some other related terminologies and associated aspects. And today I will be taking up the last chapter on the fluvial geomorphology, or I will be discussing about the last topic on fluvial geomorphology as per the syllabus of junior certificate course in surveying technology, that is the drainage patterns that we will be discussing today. So in the very first, what I want to discuss with you, what do you mean by the term drainage pattern? The term drainage pattern basically means the pattern that is being prepared, that is being formed by the streams that is flowing in a particular drainage basin. Now this drainage pattern is basically the resultant of the topography as well as the gradient or slope of the region. So two things are coming up from this particular perspective. As you can understand, topography means the terrain of the particular region. So in terms of the survey, mapping of the terrain is one of the most important aspect, or in other words, if I can say in some other way, if we can be able to identify the terrain of a region, then we will be drainage pattern of a region, then we would be able to understand or have an idea about the terrain of the particular region. Because terrain is not only the thing that is associated in terms of shaping out the land use, land cover, but it also affects or it takes due care of the contour or the relative level or the reduced level in the terms of the language of the survey, as we used to say. So today we will be discussing about the different drainage patterns and the instruments that we can use to map up this kind of drainage patterns or map up such kind of terrains basically. Now in this context, it is essential to discuss the basic notion or the basic concept about drainage basin. Now what does the drainage basin means? Drainage basin basically means the geomorphological unit or a topographical region from which the runoff, that is the stream receives its runoff, its through flow as well as that of the groundwater flow. Now the number, size and shape of the drainage basins that are found in an area used to vary, and larger the particular topographical map, that is the larger is the area that is to be covered, the more that is the information of the drainage usually that is available. Now in the very context, let's have a look into the different types of drainage patterns that usually exist on the surface of the earth. Among them, the first and the foremost and the most important being the dendritic pattern of drainage. In the very next, we can mention about the parallel drainage pattern. After that, it is the trellis drainage pattern. After that, it is rectangular drainage pattern. After that comes the radial drainage pattern. After that comes the centripetal drainage pattern. After that comes the deranged drainage pattern. After that comes the annular drainage pattern. After that comes the angular drainage pattern. Next, discordant drainage pattern, and finally the last one is the accordant drainage pattern. So these are basically the different types of drainage pattern that we used to see or that we used to come across over the surface of the earth. So now let's start off with the discussion in terms of the dendritic drainage pattern. Now what does this particular term of dendritic drainage pattern means? The dendritic drainage pattern means the most commonest form of the drainage system, and in this kind of drainage system usually we used to have a good number of streams which acts as a tributary to the major streams, and sometimes this particular kind of this drainage pattern is also regarded or is also exemplified as the join as the tributary to the major streams and used to develop up the trunk stream finally. Now this kind of drainage pattern actually follows up the slope of the terrain and are usually found basically in the V-shaped valleys, as a result of which the rock types that is found in this region is basically impervious and non-porous. So in terms of the groundwater, we can, if we have to speak about, then we can say that this type of drainage is not so much conducive. This is point number one. While the second point is that now if we have to discuss that what is the type of the instrument that can be used for surveying this kind of region or this kind of area, then definitely the answer will be the auto label, because auto label helps us, or auto label can help us to find out every single variation in terms of the slope of a particular region from one grid to that of the other grid. So therefore, if we can use up the auto level, then we can have a micro level variation of the slope that is taking place in every single specific region or area of the particular region that we are concerned with or we are mapping. So hence, if you are being asked in form of a short question that in a dendritic pattern of drainage, what is the type of instrument that we can use this, the answer will be basically the auto level. Now after the auto level, the next one is the parallel drainage pattern. Now what does this parallel pattern of drainage means? Parallel pattern of drainage basically means lesser number of tributary streams joining the main river, and secondly it used to means comparatively steeper slopes in regions through which the river is flowing and the particular area has also got certain relief or certain height of its own. Another important fact that you will have to consider that all of the streams in this kind of drainage pattern shall follow in the same direction. So therefore, this system is basically formed on the uniformly sloping surfaces. For examples, if I have to give you with an example, you can very easily write about the Aberdeen mountains in Kenya, which shows a similar kind of pattern of the drainage. Now, one thing that you will have to understand is that parallel drainage patterns is basically formed in such regions where there is a pronounced slope of the surface. Now, a parallel pattern it can also be seen to be developed in the regions of parallel and elongated landforms like outcropping that are resistant to the rock bands. So here it is the diagram where you can see that this is basically the trunk stream as I am showing you, and these are basically the tributary streams. In comparison to that of the dendritic pattern, where you can see that a good number of streams are joining up the major stream as the tributaries, herein you can see a comparatively lesser number of streams, number one. And secondly, these particular streams are flowing through the comparatively steeper slopes without having some relief, and as a result these respective streams are comparatively swift and are usually straight. So this is the most important aspect or context when we are speaking about the parallel drainage. Now let's discuss about the respective instrument that we can use if we have to map up such kind of topography region. Now the respective instrument that can be used to map up this kind of parallel drainage regions is the electronic totostation, because electronic totostation can be used to measure up such areas that shows comparatively steeper slopes, or it can also be used in such areas that has got variation in relief and that relief variation is very perfectly mentioned, or it can be shown if we are using this ETS in comparison to that of the auto level or some other context are concerned, because there may be some kind of errors or some kind of problems in form of the error corrections. Now trellis drainage pattern. Trellis drainage pattern, when I'm speaking about that, basically reminds me about the vines. Now what used to happen is that this kind of drainage patterns are basically formed when the river moves through the strike valley. A very smaller number of the tributaries used to join up the mainstream, and when they are joining the mainstream, they are joining at almost 90-degree angle. Now this 90-degree angle joining is leading or providing up an appearance like that of a trellis pattern or that of a vineyard pattern. As you can see in this respective diagram, there you can see are being joined by lesser number of tributaries, and all of the tributary streams or the smaller streams or the micro order streams are joining them at 90-degree angles directly. Now, where we can see over the earth surface this kind of drainage pattern, the example may be the Appalachian Mountains in North America, or it may be the northern part of the Trinidad Island. There we used to have this kind of the release drainage pattern. Now, in terms of the instrument, obviously it is the electronic rotor station, as I have explained in my previous pattern also. Now, in terms of the rectangular drainage pattern, this kind of drainage patterns are basically being found in the areas that has undergone tectonic movement. That is, I am basically speaking about the folding or the faulting, and especially the faulting. And actually what happens is that, as it has been reflected when we have mapped this kind of drainage pattern using the satellite data, or we have interpreted the satellite data to map up this kind of drainages, it has been found out that the stream basically follows the path of least resistance and thus are concentrated in spaces that have the exposed rock. And not only that, those exposed rock are the most weakest. Or in other words, such kind of the drainage are usually being found to follow the line of the fault or the fault plane basically. Now, the movement of the surface due to the faulting offsets of the direction of the stream. That's what I have mentioned, that the streams used to follow the fault plane. So, as a result, what used to happen? The tributary streams used to make sharper bends and enter the main streams at higher angles. As you can see in this particular diagram, this is the main river and these are the tributary river. So, all these tributary rivers are basically joining up the main stream in form of a rectangle at a comparatively higher angles of 90 degree or more than that. And in terms of the instruments that can be used to map up this kind of drainage, if we have to explain, then either we can go for the theodolite or we can go for the autolevel. So these are the two instruments that can be used to map up this kind of drainage oriented areas. Now, radial drainage pattern. Radial drainage pattern actually takes place when the streams radiate outwards from a central high point. So, if I am giving you a very basic example on India, in the Ranchi Plateau, we can have this kind of drainage pattern, where it is being found that the Ranchi upland areas or the Ranchi small hills being used to be or act as the source point of different type of drainages that used to radiate out in different directions. Now, the other geological factors or other geological features that used to develop this kind of drainage also, if we have to mention, then we can mention the name of the lopoliths or we can mention the name of the domes. Now, one thing that needs to be testified or that needs to be told to you, that basically this kind of drainage pattern are found in the areas that has undergone volcanic eruptions or that has undergone the presence of the volcanoes. So, these particular features like lopoliths, laccoliths, faccoliths or the domes are basically being exhibited or basically being controlled or governed by the drainage pattern that is named to be as the radial drainage pattern. As you can see, this is just a schematic diagram. This is just imagine this is the highland region, and from this highland region these different drainages are being radiating out in different areas in different direction. So this is the story behind the radial drainage. Now, if we have to map up this kind of area using the field survey, then the most convenient method or the most convenient instrument that can be used may be in form of the electronic rotor station, or we can take the measurement by using the DGPS, that is the differential global positioning system. Now, centripetal drainage pattern. What used to happen in centripetal drainage pattern? It is almost similar to that of the radial drainage pattern, but the only difference is here the drainage flows in comparison to that of the previous one. That is, in this particular diagram, if I am explaining through it, drainages are coming from different direction and they are flowing into this particular region. Basically, this kind of drainages are seen if there is some kind of natural lake that has been created by some kind of tectonic movement or some kind of faulting or something like that, that ultimately leads to the formation deranged drainage pattern. Actually, deranged drainage pattern means the particular region where it is found has got tectonic movements, several number of movements. It does not have a zone of sanctity. That means it used to be very violent. Or in other words, in terms of the geomorphology, if we have to define it, then a deranged drainage pattern is the drainage system in drainage basins where there is no coherent pattern of the rivers and the lakes. Basically, it used to happen in the areas where there has been a good number of the geological disruptions. Now, the most classical example of such kind of the deranged drainage pattern is the Canadian Shield. But what has happened during the last ice age, the topsoil in this particular region has got scrapped off, leaving mostly the bare rock. Now, the melting of the glaciers left land with many irregularities of elevation and a great deal of the water to collect in the low points, explaining the larger number of the lakes that are basically found in and around the Canada. Now, these drainage basins are basically young and are still sorting themselves out. So eventually, in the due course of time, we hope over several hundreds and thousands of years, such kind of the drainage basins will systematize and will get stabilized. So let's take a look into this particular diagram. Here you can see it is basically a mixture or jumblage of the several particular patterns of drainage. Be it a parallel drainage pattern, somewhere resembling the dendritic drainage pattern, or somewhere resembling the trellis drainage pattern or the rectangular drainage pattern. And you can see that, as I have told you, basically a lake or such kind of things used to govern, or a river. So this is here the example of a particular lake that is existed in this particular drainage pattern. So after the deranged drainage pattern, let's go into the annular drainage pattern. So in annular drainage pattern, streams basically flows through a roughly circular or concentric path along a belt of weak rock, resembling in plan a ring-like pattern. You just see here, this particular drainages have formed a ring. It is just resembling that a ring has been formed. This kind of drainage are best displayed by streams draining a maturely dissected structural dome or basin where erosion has exposed the remaining sedimentary strata of greatly varying degrees of hardness, as it has taken place in the case of the Red Valley, which nearly encircles the domal structure of the Black Hills of the South Dakota in United States of America. Now, one thing we have to mention, that if we have to map up the drainage of this kind of region, or if we have to map up the region having this kind of drainage, then the most convenient instrument that we can use to map is the auto label, or we can also use up the differential global positioning system. And because in both the cases we can have a comparatively greater reliability of the data in terms of the terrain or ground is concerned. Now, the last two drainage patterns, one is the angular drainage pattern, while the other is the discordant drainage patterns. Now, what is angular drainage pattern? Angular drainage pattern are basically formed when the bedrock joints and faults intersect at more acute angles than the rectangular drainage patterns. Usually, angles are both more and less than 90 degrees. So, this particular kind of drainage pattern, as I have been mentioning, is the more modified form of the rectangular drainage pattern, where in the rectangular drainage pattern we have seen that drainages are basically joining each other at 90 degrees or something like that, or in the case of the trellis drainage pattern that I have mentioned. So this particular kind of the angular drainage pattern can be summed up as the more modified form of the angular drainage pattern. And the most convenient instrument to measure up such kind of terrain is the electronic total station, definitely without any kind of point of hesitation. And if we are speaking about the discordant drainage pattern, what is the discordant drainage pattern? A particular drainage pattern is described as discordant if it does not correlate to the topography and the geology of the area. Now, these are classified into two basic types. One may be the antecedent drainage pattern, while the other one may be the superimposed drainage pattern. while the anteposition pattern, a river's vertical incision ability matches that of the land uplift due to the forces of tectonics. Now, in case of superimposed drainage pattern, what used to happen? In case of superimposed drainage pattern, initially a drainage system is developed on a surface that is composed of the younger rocks. But due to the denudative activities, the surface of younger rocks is removed and the river continues to flow over a seemingly new surface that one in fact make up of the rocks of the old geological formation. So this is in short about the different kind of drainage pattern, and as I have been speaking you about the different kind of the instruments that can be used to measure up this kind of the drainage pattern. So you have learned through this particular lecture that either to map up the terrain having the different pattern of the drainage, the most convenient instruments that we can use either may be that of the auto level, or it may be the electronic total station, or it may be the differential global positioning system, that is the DGPS. While I would like to request you to refrain from using the GPS except for the cases that the mapping of the region you are doing is not in a regional scale. That is, if you have to prepare a map in 1:2000 scale, then refrain from using of the GPS because that data will not be 100% accurate. But if you were preparing a map into 1:50,000 scale, obviously you can go for the GPS because GPS data has got an error level of ±3 meters. So that you will have to keep in mind. Then with this, I would like to tell all of you that please stay happy, please stay tuned, be safe, stay at home and follow the rules as has been directed by the different provisional state governments or by the government of India in terms of this COVID situation. I would like to wish all of you thank you so much for your patience. That's all. Goodbye. Jai Hind. Vande Mataram.